Thank you very much, Matsumoto-san. And it's wonderful for all of you to join. I'm really honored that all of you have come to join with today. And it's my honor to be able to speak with the Toastmasters. Um, one thing I'd just like to mention is that a lot of the field work gathering these oral histories that I've conducted, that this talk will be based on, was conducted with a colleague of mine, Dr. Mick Broderick, from Australia. And it was last month I was down consulting with him and doing field work in Australia, and forced me to postpone this meeting to today. So I'm grateful to you all for accommodating that research need. Um, pardon me. So I'm going to share my screen and give you a bit of an overview of global hibakusha issues, but primarily locations where people have been exposed to radiation since 1945 and how that happened and some of the complications of these exposures. Um, Hang on one moment. There we go. And are people able to see clearly? Okay, great. Um, let's see. Hang on one moment. Well, this talk is about the global hibakusha. Especially being here in Hiroshima, you all are well aware of the meaning of the word hibakusha. Um, Hibakusha are the people who were directly attacked by nuclear weapons here in Hiroshima and in Nagasaki, people who lost family members, people who were wounded, people who lost their homes, people who endured exposure to radiation and ongoing illness. And these are the only communities in Hiroshima and Nagasaki where people have been directly attacked by nuclear weapons. However, uh, since 1945, there have been lots and lots of other people exposed to nuclear radiation from nuclear weapons and from nuclear technologies. And these communities are known to scholars and to activists as the global hibakusha. The primary way that they've been exposed to radiation is from nuclear testing, nuclear production, the production of nuclear weapons, and the production of fuel for nuclear reactors, and through nuclear accidents. Um, so here what you see is a map that shows most of the global nuclear test sites where nuclear tests have happened. So let's look a little bit closer at it. Um, Nuclear testing has happened, as you can see here, on every continent except South America and Antarctica. However, there were also nuclear accidents on Antarctica and in South America as well, but not nuclear testing. Since 1945, there have been over 2,000 nuclear weapon tests. Nuclear weapons are so big that when they are tested, it is impossible to contain their effects to the test sites. Pardon me. Primarily radioactive fallout. Radioactive fallout has tended to come and spread into downwind communities after every nuclear test, and especially after tests of hydrogen bombs or thermonuclear weapons, which I'll talk about in just a little bit. We tend to think of the Cold War as a period of time in which nuclear weapons weren't used. However, during the Cold War, statistically, there was a nuclear detonation every 8.6 days, over 2,000 tests. So nuclear weapons were exploding constantly during the Cold War. And millions of people around the world were exposed to radiation as a result of that. So here's a map that shows some of the primary test sites, but with some numbers added in there to give you a little bit of context. The place with the most nuclear detonations on Earth is Nevada in the United States, with over 900 nuclear weapons detonated at the Nevada test site of the United States. The primary test site of the former Soviet Union was in Kazakhstan, almost 500 nuclear weapons detonated at the test site in Kazakhstan. And I'll go through these sites a little bit more specifically later. But this is to give you a bit of an overview that this testing was going on all over the world. And lots of communities were exposed. This map's a little old, so North Korea, it says one, but there were more in North Korea. Now, to understand some of this, some of the ways people were impacted, I need to just briefly talk about nuclear weapons themselves. And when a nuclear weapon explodes, we tend to describe the nuclear weapon effects as three basic things: blast, heat, and radiation. These are all forms of energy that come out from the detonation of the nuclear explosion. Blast and heat, every explosive has blast and heat energy. Of course, nuclear weapons are just much larger than conventional bombs. What is unique to nuclear weapons is radiation. And what's very important for the history of the global hibakusha is the fact that we are affected by radiation in two distinct ways. That's why I have that S there. The way we tend to talk about this is prompt radiation and residual radiation. Residual radiation, we tend to know by the expression of radioactive fallout or fallout clouds. The primary difference between prompt radiation and residual radiation is that prompt radiation is in the form of radioactive waves, and radioactive fallout is in the form of radioactive particles. I don't want to go too much into detail. I'm happy to in the question time, but just to give you an idea, prompt radiation, radioactive waves, they're very much like X-rays. So when you have an X-ray, you put your arm on a photographic plate and the X-ray is turned on and then turned off. When it's turned on, the radioactive waves go through your body and make an impression on the plate, and then the X-ray is turned off. There's no more radiation. So it's gone through your body and we have this picture of your bone. So when a nuclear weapon explodes, there's a giant burst of radioactive waves, but they're gone in less than a minute. It's like an X-ray. It's on and off. So for people that are close to the nuclear explosion, those radioactive waves will pass entirely through their bodies. And if they're very close, they will get a very large dose that may kill them quickly. If they're a little further away, they will get a smaller dose and it may do damage in their body and make them sick. But all of this damage happens within a minute, and then slowly disease can progress inside of someone. The particles are individual radioactive chemicals, particles that are made radioactive. These are different because they stay radioactive, sometimes for a long time. Different chemicals can stay radioactive for a few days or even up to 1,000,000 years. So after the nuclear explosion, the particles present an ongoing risk and can make people sick years and years later, decades later even. So the people at the nuclear test sites were not close enough to the explosions for the blast, the heat, or the burst of radioactive waves to affect them. But fallout clouds would come over and drop these particles, these radioactive fallout particles where they live, and it would make them sick, and it would also get into their food supply and get into their water supply and stick around for sometimes into their grandchildren and great-grandchildren's lifetime and beyond that. So these people, the global hibakusha, are primarily affected by the fallout. For those of you here in Hiroshima, you can think of it similar to the people who lived where the Black Rain was. The global hibakusha have gotten sick similarly to the people where the Black Rain fallout fell in Hiroshima after the explosion. Now, before I start talking about specific locations, I also want to talk about one more thing, and that is the size of nuclear weapons. We tend to measure the size of a nuclear weapon by the power, the amount of energy in the blast, the explosion. We call that the yield of the nuclear weapon. Nuclear weapons are so large that we tend to measure that blast by how many tons of TNT would it take to make the same explosion. So here in Hiroshima, we tend to think that the explosion was around 14 or 15 kilotons. That means that to have an explosion the same size as the explosion in Hiroshima, you would need 14 or 15,000 tons of TNT to explode at the same moment. So that's how large these weapons are. Now, less than 10 years after the nuclear attack on Hiroshima and the attack on Nagasaki, both the United States and the former Soviet Union developed another kind of nuclear weapon called hydrogen bombs. They're also called thermonuclear weapons. Hydrogen bombs work completely differently than the kind of weapon used in Hiroshima. The kind of weapon used in Hiroshima works by fission, by splitting the atom, by splitting the nucleus of the atom and releasing the energy that holds the nucleus together. Hydrogen bombs work through a process called fusion, which means fusing together the nuclei of two atoms. This is how stars work. So wherever you are right now, the light and the warmth that you feel is coming from nuclear fusion in the sun. So we figured out how to make bombs that could do this, hydrogen bombs. Now, the key thing for this history is that hydrogen bombs, there are no limits to how big you can make them. And so the first hydrogen bombs we made were 1,000 times larger than the weapon used in Hiroshima. Hydrogen bomb yields we measure in megatons or millions of tons of TNT. So the largest US hydrogen bomb test, the Bravo test, which I'll talk about in a few minutes, we measure it at 14 megatons. So you would need 14 million tons of TNT to explode at the same moment in order to get an explosion that big. As I said, there's no limit to how big you can make them, and the Soviet Union once detonated one that was 50 megatons. By contrast, you can see how small the Hiroshima explosion was compared to hydrogen bombs. Now, one of the reasons that this is important for the story of the global hibakusha is that these mushroom clouds go up much, much higher in the atmosphere. They're much bigger, and they carry the fallout to the upper atmosphere, to the stratosphere. And there, the fallout particles would circle the Earth for years and years and years before they would fall. Many would fall close by to the test, but many more would go into the stratosphere. And as a result, they have spread all over the planet. So there's a lot of fallout all around the world from hydrogen bomb testing. Now, one more note before I talk about specific places, and that is that a key concept to how nuclear test sites are chosen is the idea of colonialism. In a sense, there are two kinds of colonialism at work with nuclear material. There's a traditional extraction of resources like uranium mining, which tends to happen in poorer places. This is the Shinkolobwe mine in the Congo, where a lot of the uranium for the Hiroshima weapon came from. So this is traditional kind of colonialism, resource extraction. But there's a new kind of colonialism in nuclear weapon testing, and that is deciding that some place is no place, where there is no one, and it doesn't matter what you do there. So, for example, many nuclear weapon states looked at the Pacific and they thought, that's just a big empty place, and we can test these giant hydrogen bombs there, and it won't affect anybody. And so there were a lot of hydrogen bombs tested there, but of course, it's not true that it's no place. It's actually a lot of islands, a lot of places where people live. There's a lot of people living out there. It's not empty, and it does matter what you do to people. But there were nuclear weapon test sites all over the Pacific. None of these countries where these test sites are had nuclear weapons. These were tests that were being done in colonial spaces or post-colonial spaces or territories that were held in trust by nuclear weapon states. Um, so I'll point that out a little bit more as we go on, but now I want to talk specifically about the first 5 nuclear weapon states. The first 5 nuclear weapon states all tested nuclear weapons in the atmosphere, and as a result, they spread fallout clouds. Later nuclear weapon states, including North Korea, all tested underground, and so the fallout stayed near the test sites. So I'm going to look at the countries that spread fallout clouds nearby their test sites. The United States tested over 1,000 nuclear weapons. They tested 67 of them in the Marshall Islands, which was a trust territory that the United States held after World War II. They tested over 900 in Nevada, a domestic test site inside the United States. And they also tested 22 weapons at a test site in a Pacific nation called Kiribati. It was a British test site, and they tested there. The US had a policy of only testing hydrogen bombs in the Pacific sites. So even though 900 of the weapons were tested in the US, they tested all of the hydrogen bombs in the Pacific to keep those giant fallout clouds outside of the United States. And this is one way to see that they knew people would be harmed by it. Now, here is the Nevada test site, is located right about there, just north of Las Vegas. This map shows fallout cloud tracks across the United States. These are all tracks that fallout clouds took across the United States. And after the atmospheric testing period, it left large amounts of contamination. Huge areas of contamination in the Mountain West, in Utah, Arizona, in Western Colorado, in New Mexico. So here by the test site, there was a lot of contamination, but you'll notice that there were here, these colors show the scale of fallout, and the brown is much, much higher scale, where there's much, much higher radioactive contamination. So you'll see there's also very high levels in some places far away. These are places where it rains or snows a lot because precipitation tends to bring fallout down in much higher amounts. And just to give you an idea of the way that this kind of contamination remains for a long time and affects people who aren't even thinking about it, I want to show you another map. This is a map of the eastern seaboard of the United States. And in 2021, 3 years ago, a study was done where researchers took 122 samples of honey from places in the eastern seaboard of the United States, and they were looking for radioactive fallout from Nevada tests, specifically for the radioactive particle cesium-137, which lasts about 300 years once it's fallen down to the ground. They found cesium-137 in over 50% of the honey samples. So here it is, 70 years later, after the testing in Nevada, several thousand kilometers away, and 50% of the honey samples showed the presence of radioactive fallout from these tests. So once this material comes down, it endures. Now I'll talk about the Bravo test. This is the US's first real hydrogen bomb test, its largest hydrogen bomb. This photograph of the Bravo test is taken from about 70 kilometers away by an airplane up in the sky. It was an incredibly large weapon, but one of the things that is more important about it is the fallout cloud. So this is the fallout cloud of the Bravo test about 16 minutes after the explosion. It's beginning to spread out across the Pacific. The US military made this map of the fallout cloud. This is about 4 days later. It was spread across the Pacific. And these levels of radiation, by the way, are incredibly high. So as you can see, it engulfed atolls. These are places where there were hundreds of people living at the time. So at Rongelap Atoll, the day of the test, US radiation monitors came to Rongelap to see how the radiation levels were, and it was so high that they panicked and left. 2 days later, a US Navy ship came and told all of the people on these atolls, you have 1 hour to gather your belongings, and we're going to evacuate you because of the radiation level being so high. And so you have to be prepared to leave for a few weeks. So people gathered their belongings and they left, and they still cannot go back and live on these atolls today. They're still too radioactive today. This was a test in 1954. Up here is where was the Daigo Fukuyomoru, which probably many of you have heard of, the Japanese tuna fishing boat that was about 100 kilometers away from the test. And about 3 hours after the test, radioactive fallout fell on this boat for about 5 or 6 hours. When the boat came back to port, 2 weeks later in Japan, the entire crew was hospitalized with radiation sickness. One crew member died 6 months later from complications. So here you have somebody that is 100 kilometers away from a hydrogen bomb test, and it killed them in 6 months. The US took this map and they tried to imagine what would happen if this weapon were detonated on Washington, D.C. So this is the same fallout map, but now you have a sense of scale. It's hard to understand size and distance in the Pacific. What they determined was that if this weapon was used on Washington, D.C., everybody in Washington, D.C. would be killed by the blast and the heat of the explosion. But also, the entire population of Baltimore, the entire population of Philadelphia, and 50% of the population of New York City would die unless they evacuated immediately. And what would kill them would be fallout. During the Cold War, all nuclear weapon states used the idea of fallout as a weapon to kill enemy troops and enemy populations. So when people were harmed by it in tests, this was as though they were enduring a nuclear attack. Now, the next country to develop nuclear weapons was the former Soviet Union. They conducted 715 tests, 456 in Kazakhstan near a town called Semipalatinsk. Now it's been renamed as Semi. 224 in the Soviet Arctic at Novaya Zemlya, and also several more at multiple sites around the former Soviet Union. So here in Kazakhstan, here was the test site known as the Polygon in Kazakhstan, and here is a local map of it. These are all villages downwind from the test site. And you can see by this scale here, some of them are 20 kilometers away from this test site where there were 500 tests. Some of them are so close that they had to pretend that the test site didn't go right through it. So they drew the map as though this village wasn't in the test site. They tested regular weapons and also hydrogen bomb weapons there. So very, very huge hydrogen bomb clouds spread across all of these villages. I would mention that doing field work, there's much higher levels of sickness among third and fourth generation people living in these villages because they're living in areas that had heavy contamination from hydrogen bombs, and they're still getting all of their food from these kinds of locations. A lot of the larger Soviet hydrogen bomb tests were done in Novaya Zemlya, which is in the Arctic. For example, the Tsar Bomba, the 50 megaton weapon. This is in European Arctic. So this is not that far from Finland and Norway and Sweden. And so there were over 200 weapon tests up there, many of them extremely large hydrogen bombs as well. The next country to develop nuclear weapons was the UK. 45 nuclear tests, 12 nuclear tests in Australia, where they started. Then they tested their hydrogen bombs in the Pacific in Kiribati. And they also conducted some tests at the Nevada test site in collaboration with the United States. Now, notice what's missing from this list. No tests inside the UK. The UK never detonated a weapon inside their own country, only in post-colonial spaces. And that was because they understood that these tests were going to harm people, so they kept them away from their own citizens. They began testing in Australia, a former colony. They tested it first off the coast of Western Australia and then in Southern Australia at Emu Field and at Maralinga. Uh, They put up signs to warn Aboriginal communities that were living in this area about the test site. However, at this time in the 1950s, many of the people that were living in many of the Aboriginal communities were not English speakers. And so people did not understand these signs telling them that something dangerous was going to happen there in the land where they lived and where they gathered food. Radiation hazard signs were put afterwards to let people know where there was contamination. But again, people couldn't read these signs. So it really wasn't doing them very much good. The Australians would not let them test hydrogen bombs in Australia, so they went out to Kiribati in the middle of the Pacific Ocean, where they tested their hydrogen bombs on an island called Christmas Island. Here, just to show you, these are all Christmas Island Hibakusha. These are people who were all children at the time that the nuclear testing happened. And they are just now understanding that many of the cancers in their community are related to the radiation. The British gave them no information about this at all. So even when we visited there, we've helped people to rebuild the history of when the testing was, where the testing was, and what the effects of radiation were on people. The next nuclear weapon state was France. 217 nuclear tests, 22 in Algeria, and then 195 in French Polynesia. So again, what's missing here? No tests inside France. In this case, testing only in actual colonies. When they began testing in Algeria, Algeria was a French colony. The Algerian War of Independence was raging, and France knew they were going to lose possession of Algeria as a colony. So even from 1960, when they began in Algeria, they started building a second site in their colony in French Polynesia, where they tested most of their weapons. In Algeria, the French tested weapons in the desert in sub-Saharan Algeria, and so down here, and a lot of the radiation spread all across Western Africa, in many parts of Western Africa. And when the French quickly abandoned the site, they simply walked away from it and left a lot of the waste just sitting there and did nothing to protect the local community from it. And many people have dug up a lot of the metals and sold them, and we have found radioactive material in markets throughout Western Africa. They went down to French Polynesia. They tested their weapons at two atolls down here in the southeast part of French Polynesia, and they tested lots and lots of hydrogen bombs there, including into the 1990s. They continued testing in French Polynesia. They claimed that the fallout all stayed very close to these small, very low inhabited atolls, but recent releases of information from the French government have showed that multiple fallout clouds engulfed Tahiti and all of the very populated parts of French Polynesia. So there is increasing information coming out about the contamination of essentially the entire population of French Polynesia by the French. The next nuclear nation was China. China conducted 47 nuclear tests. All of these were conducted at Lapnor in Xinjiang province. As many of you know, so here's where the test site was in Lapnor, and this is the traditional homeland of the Uyghur population. Many of you probably know that there has been ongoing brutality against the Uyghur population in China and suppression of the Uyghur population. And here they tested both hydrogen bombs and smaller Hiroshima-style bombs. So even when nations test domestically inside their own borders, they typically test nearby communities that are ethnic or religious minorities, which is what the Uyghur population is. So in every case, all the nuclear weapon states, regardless of their ideology, Their strategies for testing nuclear weapons are identical, which is you either test outside of your country in colonial spaces where people can't stop you, or if you test domestically, you test near people of a different ethnicity or people of a different religious culture than the dominant population. Kazakhstan, the Kazakh test site, is not far from the Uyghur test site. So in both cases, the Soviets and the Chinese tested in Central Asia near Muslim populations that were not majority populations. There's a small sign denoting the last atmospheric test on Earth in 1980 in China, in the Lop-Nor region. I'll just quickly mention too that there's been a lot of fallout from nuclear reactor accidents. Nuclear reactor accidents tend to spread radioactive particles similarly to nuclear tests. Some of the first nuclear accidents are at places we haven't heard of because they happened in the military reactors. I don't know if you know this, but nuclear reactors were not invented after nuclear weapons. Nuclear reactors were invented by the Manhattan Project. They were invented before nuclear weapons. Nuclear reactors were invented to make plutonium. So all of the first nuclear reactors in the world were military nuclear reactors to make plutonium for nuclear weapons. In England in 1957, in their military reactor in Cumbria, there was a fire at the Windscale reactor. The reactor is located up here, and they claim that none of the fallout left the site. However, the Irish Centre for High-End Computing has recently done an animation that recalibrates the spread of fallout from the Windscale fire. This was a fire inside a nuclear reactor. It burned for 3 days. It was a reactor only making plutonium, not making electricity. And since the narrative was controlled by the UK government, they were able to claim that none of the fallout left, and people didn't know how to understand whether it did or not. But it was such a notorious thing, they then changed the name of Windscale to Sellafield, which is what it's called today. And as you can see, the fallout engulfed most of the UK and Ireland, as well as Scandinavia. More familiar to us is Chernobyl. After the explosion at Chernobyl, a fire burned inside the number 4 reactor for over 4 weeks. And this fire spread fallout all across Europe. We first became aware of the Chernobyl accident because nuclear power plants in Sweden began to pick up radiation. The Soviets did not say anything about Chernobyl, but we were aware of it because this radiation was spreading around Europe. During the 4 or 5 weeks that the fire burned, the winds spread it around most of Central, Northern, and Eastern Europe. And it contaminated vast areas. Here is a map of the contamination of cesium-137 in 1986. So you can see there are multiple places with very high levels of contamination, some close by to the Chernobyl site, but also some quite distant from the Chernobyl site. And cesium-137 remains dangerous for 300 years. So 10 years later, there's still significant contamination in all of these places. We still remove radioactive food contaminated with Chernobyl contamination every year. We continue to find it. As you all know, there were 4 explosions and 3 full nuclear meltdowns here in Japan at 311. When these explosions go up into the air, the wind has them drift just like a fallout cloud. And in Fukushima, a lot of the fallout drifted to the northwest. So this is a map of the contamination as it spread out into the areas far away from the plant and on into Tohoku. After radioactive contamination, this is a photograph, by the way, I took in Kazakhstan of trying to grow plants in contaminated soil to see how contaminated they are. But once the fallout comes down, this is a lot of what people have to deal with. Sickness and early mortality, continued habitation on contaminated land. This is true in Kazakhstan. Producing food from contaminated land or water. Forced displacement by governments. The people from Rongelap and the people in the atolls in the Marshall Islands were forcibly removed. They lost their homes, they lost their possessions, they lost inheritable wealth they could pass on from generation to generation. Uncertainty about the health of self and family. This is similar to what many Hibakusha in Hiroshima and Nagasaki have experienced. Even if you don't get sick, you don't know if you're going to get sick. Each time your child has a nosebleed, you can worry that, oh, this is it. This is it. The radiation is coming from my family. And this anxiety can create a lot of distress and a lot of difficulty for people. And also disconnection from traditional lifestyle and culture. People that are forcibly displaced from where they live. For example, Aboriginal communities in Australia that were forcibly moved from their lands where the contamination was in Australia. This is in Australia, a community that's been self-sufficient for 80,000 years in living in the desert. And when you move people from land that's difficult to live in, where they know where the water is, they know when to find water in certain places and when to find food in certain places. When you move them a few hundred kilometers away, they don't know this, and they become dependent on the state to provide food, and traditional lifestyles begin to erode. And I can talk about that in multiple communities during the question and answer if you're interested. So this was just a quick overview of some of the locations where people have been exposed to radiation and some of the things that happen to them in these specific places. I'm happy to, during the question and answer time, talk about any of this history and also some of the larger issues around contamination and radiation. And I thank you all for your attention. This is a difficult subject and a painful subject. And so thank you very much.